Welcome back to Step Electrical friends. Now we are here in mesh analysis series and this is the part 5 of mesh analysis series. In this part we will learn how to deal with dipole circuit. Okay, so let's begin. Now the title of this video is circuit containing current source along with the voltage source. But here the current source is lying between any two loops. Here in this circuit we can see that this current source is lying in between loop 1 and loop 3. So we will also see some other figures. And here we can see that this current source is lying between loop 2 and loop 3. Similarly, this current source is lying in between loop 1 and loop 2. Okay, so this is the case of super mesh analysis. So we can conclude if the current source is lying in between any two loops, then this is the case of super mesh analysis. So let's move forward. Here we can see that this current source is lying between this loop and this loop. So first of all we will assume the loops as well as the current in each loop. Okay, so let's assume that this one is the first loop, this is the second loop and this one is the third loop. After assuming the loops, we will also assume the currents in each loop. So I1 is the current flowing through loop 1, I2 through loop 2 and I3 flowing through this loop 3. So we have 3 loops and I1, I2 and I3 are the current flowing in each but in clockwise direction. Now what are the things that we have to do in the case of super mesh? So first of all, let's see the first step that we have to do. Through this current source, I1 current is flowing from left to right while I3 is flowing from right to left. On observing this branch, we can write that I3 minus I1 is equal to S. Why I3 minus I1? The direction of I3 and the direction of current flowing through this IS current is same. So we write I3 minus I1 is equal to S. So we can easily write I3 minus I1 equals S. At the very first step, what we have to do, we have to write this equation using the loop currents as well as the current produced by the current source. So we can easily write this equation, that is the I3 minus I1 is equal to S. Why I3 minus I1? Because here this IS current is in the direction of I3. So we write I3 minus I1. This equation is the first equation. Okay, so let's move ahead. So in the second step, what we see, we have to remove this branch. We have to remove this branch containing this current source. So after removing this branch, we will get this circuit. Here I3 current flows in this loop and after removing, but it is still flowing in this voltage source, R4 resistor and R3 resistor. While this I1 current, after removing this branch, it is still flowing through this V1 and R2. We will write KVL equation for this. Just forget everything. You don't have to be so worried that there are two currents in the same loop. So first of all, I will explain. I1 current is flowing through this V1. As this is voltage source, it is flowing from negative to positive. So we can write plus V1. And through this V3, which current is flowing? I3 current is flowing. But it is still flowing from negative to positive. That's why it is also positive. So we can write, as we start writing KVL from here, then we will write V1 plus V3 minus I3 into R4. I3 into R4. Thereafter we will come here and for this R3, I3 is flowing. I2 current is also flowing through this R3. So as we are applying KVL in loop 3, so we will write I3 minus I2 into R3. And for this R2 resistor, the current I1 and I2 both flows. So we will write, as we are applying KVL in this loop, loop 1, I1 minus I2 into R2. And finally is equal to 0. So this is the second equation using this super mesh. Applying KVL in super mesh 1 and 3, we will write V1 plus V3 minus I3 into R4 minus I3 minus I2 into R3 minus I1 minus I2 into R2 is equal to 0. And on simplifying this equation, we can write minus I1 into R2 plus R2 plus R3 into I2 minus R3 plus R4 into I3 is equal to minus V1 minus V3, and this is the second equation. In this step, we will apply KVL in this loop, second loop. let's apply KVL in. On applying KVL in loop 2, we can write minus V3. It is very easy because this current I2 is flowing from positive to negative. That's why we write minus V3 minus I2 minus I1 into R2 minus I2 minus I3 into R3 is equal to 0. And on simplifying this equation, we can easily write I1 into R2 minus R2 plus R3 into I2 plus I3 into R3 is equal to V3. So this is the third equation. So on solving these three equations, we will get the values of I1, I2 and I3. Now with the help of these all concepts as we do in the previous parts, we will solve a numerical. Okay, so friends, you can see here that this 10 ampere current is lying in between I1, between loop 1 and loop. So I am not going to assume the loops as well as the currents and their direction. All things is shown in this figure. I will just write the equation and then I will solve the equation and get the values of I1, I2 and I3. So the very first thing that we will do is I3 minus I1 is equal to S. Why I3 minus I1? Again here I want to say that this direction of I3 current and the direction of this current through this current source is same. That's why we can write I3 minus I1 is equal to IS. So this gives us the first equation, and on replacing these values of IS we can write I3 minus I1 is equal to 10. So again applying KVL in supermesh 1 and 3 we can write minus 4 I1 plus 6 plus 4 I2 minus 4 plus 6 I3 is equal to minus 20 minus 10. And on simplifying this equation we can write minus 4 I1 plus 10 I2 minus 10 I3 is equal to minus 30. So this gives us the second equation. And so this is the second equation. And the third equation is obtained by applying KVL in loop 2. So on applying KVL in loop 2, we can write 4 I1 minus 4 plus 6 I2 plus 6 I3 is equal to 10. And on simplifying this equation, we can write 4 I1 minus 10 I2 plus 6 I3 is equal to 20. And on solving these three equations, we can easily get the values of I1, I2 and I3. So this is the value of I1, I2 and I3.